change a given percent composition to an empirical formula. So we want to now calculate an empirical formula given the percents of the elements that are in the compound. For example, if we had something that was 75% carbon and 25% hydrogen, how can we make an empirical formula out of that? Well, that's going to be our first example, but let's go through the steps first, and then I'm going to show you how to do this. So the first step to doing this is to change the percent to grams. And that seems harder than it is, but if we assume that we have 100 grams of a substance and there's 100%, then we can just simply change the percent sign to grams. And it's as simple as that. And then what we're going to do is we're going to take those grams that we just got from step 1, and we're going to divide by the atomic mass of that particular element. And we get that from our periodic table. And that's going to give us some numbers to work with. And those numbers are really a mole ratio. And we want to find the lowest whole number mole ratio for our subscripts. So to do that, we're going to take the lowest value that we got from step 2, and we're going to divide each of those numbers by that lowest value. And when you do that, you're going to end up with a whole number ratio. Now, that seems more complicated than it is, so let's get to work and let me show you exactly how we're going to do this. Okay? Let's take a problem like this one, and it says a compound is found to contain 75% carbon and 25% hydrogen by weight. What is the empirical formula for this compound? Whenever you are trying to figure out what to do in a problem, find the question. The question gives us a lot of clues. Here's the question. It'll start with a question word, what, how, why, and then it's going to ask us, what is the empirical formula for this compound? And so we know we're looking for an empirical formula, and what we're given in the problem, let's change colors here, are percents. So we know we are changing percent to empirical formula. And as soon as we know that, we can start to go into our memory banks and pull up those 3 simple steps. Let's try one. Let's take 75% carbon. So what I like to do is I like to just, ooh, that's a really big pen. Let's erase that. Get out of there, carbon. And let's make our pen a little bit smaller so it's easier to read. Okay, let's see. Alright, carbon. And I'm going to say that there's 75% carbon, and we have hydrogen. There's 25% hydrogen. All I did was write down what was given to me in the problem. Now let's do step 1. Step 1 said change percent to grams. Well, 75%, all I have to do is take the percent off, change it to grams. 25% hydrogen, all I have to do is take the percent off, change it to grams. Because we've assumed that 100 grams of substance, then if we take 75% of 100 grams, we get 75 grams, and 25% of 100 grams is 25 grams. So all we had to do was change the sign, percent to grams. Now we're on to step 2. Step 2 says take this number and change it by dividing it by the atomic mass that you would get for carbon. So in this case, 75 grams divided by carbon's atomic mass. Let me pull that up for you so you can see. Carbon all the way over here and up here. Carbon's atomic mass is 12.011. We're going to round that to the nearest tenth. So we're going to take 75 grams and we're going to round that 12.011 to 12.0 and get my pen going again. 12.0 grams per mole. And we're going to end up with 6.25 moles. M-O-L. There you go. Alright, now let's do the same thing for hydrogen. We're going to take 25 grams. We're going to divide it by the atomic mass of hydrogen, which is 1.0 grams per mole. I got that again from my periodic table. If you don't believe me, let's pull it up so you can see. Hydrogen 1.00794. I just rounded it to the nearest tenth, so it's 1.0. Okay, so that's where I got that number from. And then we're going to divide 25 divided by 1, which is 25 moles. Okay, so that's step 2. Now step 3 is to take, come here pen, is to take the lowest mole ratio for the subscripts by dividing by the lowest value in step 2. So this right here is my lowest value, 6.25 moles. 6.25 is lower than 25. So whatever the lower number is, you're going to divide all of these by 6.25. And when you do 6.25 divided by itself, you get 1. And 25 divided by 6.25 is 4. That's my whole number ratio. So I have, let me just scroll up here. I have a ratio of carbon, which is 1, and hydrogen, which is 4. Okay, so I don't have to write that 1. Remember, subscripts of 1 are understood, so I write CH4. That's my empirical formula for this compound, which had 75% carbon and 25% hydrogen by weight.